Good morning, everyone. My name is Jing Lee, and my group mates are Eugene Ma, Lee Jun Ming, and Ling Yi Hong. Today, we'll be presenting our Assignment 1, Passive Green Building Case Studies. This project is a comparative analytical case study on two buildings from two different climate types, and to study and compare the differences between the type of green buildings design strategy applied to respond to their respective climates. The buildings that are studied are Nanyang Technological University in Singapore and the Pixel Building in Melbourne, Australia. So I'll start with introducing the Nanyang Technological University that is located in Singapore with tropical climate. The university is a national research university based in Singapore. It is the second oldest autonomous university in Singapore and considered to be one of the top universities in the world. The building promotes passive design strategies that are directly attached on the building and cover majority of the building. For the site planning, the building is located in a housing area with a proper development from the Singapore's government. It is situated far from the main city and surrounded by natural vegetations. For the accessibility-wise, it is situated at a crossroad between Nanyang Avenue and Lian Ying Chow Drive and is flanked by the Sim Tech Valley block. For the climate analysis, Singapore is situated near the equator and has a typical tropical climate with abundant rainfall, high and uniform temperatures, and high humidity all year round. Many of its climate variables, such as temperature and relative humidity, do not show large month-to-month variations. For the building orientations, Malaysian and Singapore's buildings receive high solar radiations, mainly in the west and east facade in the afternoon. The sloping green roof has helped to minimize the west opening shades to the rest of the building. The building is facing north and south to avoid high incident solar radiations on east and west. The axis of the building runs west-east to maximize exposure to natural daylighting. With the facade facing east, they install with double-glazed glass to maximize daylighting while regulating the temperature for the building. The highest velocity wind hails from the east part of the site. Therefore, a cross-ventilation structure is designed to allow natural ventilation throughout the building to regulate the temperature with openings. For daylighting, Singapore's yearly direct normal irradiations is a total of 1,580 to 1,620 kilowatt-hours per square meters. The sun path analysis shows that the diagonal orientation maximizes daylighting mainly in the west and east facade in the afternoon. The sloped green roof helps minimizing the west openings, thus shading the rest of the building. The low E double-glazed glasses windows are applied in this building. This type of window is used on the building in order to allow natural daylighting to penetrate the building while reducing the amount of heat entering the building. The placement of the windows right above the ground is to help illuminate space underground, and the glass opening in the interior walls is allowing the penetrations of the light. Green roof system is also a main feature in this building. The roof creates open space, insulations for the buildings, cool the surrounding air, and planted grass mixed with native greenery to colonize the buildings and bond it to the settings. For the facade, this fascinating building has many interesting twists, such as an unusual curved twin roof, a landscape garden, and a stick curtain wall. The facade also acts as a mirror and reflect of the surrounding greenery, water, and sky, thus expanding the visions of nature. When the sun sets, the lit-up interior of the building are fully exposed and building glow from within like a lantern. There are four main components in the building. The first one will be the water bodies courtyard. It is providing cooling properties for water attribute exuding a serene environment and the refreshing breeze that cools the courtyard. The second one will be the double glazed glasses. The exterior glass curtain railing is utilizing passive solar designs to help maximize natural lighting by using proper orientations and providing appropriate shading to avoid overheating. The third one will be the almond-shaped courtyard. The courtyard expands access to daylighting and cooling effect. It provides natural lighting into the interior space as well. Next will be the green roof design. It helps cool down the building in the daytime and also can be seen from the planting of vegetations on the east side of the campus, creating a shade buffer from the morning sun. It is sloped almost at a 45-degree angle and formed by two sloping, tapering that interlocking with a third. For the materiality, the first and obvious one will be the double glazed glass. It helps maximize natural lighting by using proper orientations and providing appropriate shading to avoid overheating. And the second one will be the raw concrete. It has ability to help in absorbing and retaining heat. And the third one will be the brown stone walkway. It is low maintenance natural stone and it is highly durable and long lasting. For the sustainable facade feature, which is the green roof, it reduces water runoff from heavy rain and growing media of the green, which are the volcanic rocks and sand together with the turf grass, can hold water and the water will go into rainwater harvesting to reuse. For the green roof energy efficiency, The green roof can lessen the rate of the heat energy transfer through the roof, and lesser amount of the energy for cooling means greater cost saving. During the day, the green roof protects the building from direct solar heat, and during the night, the green roof reduces the loss of heat energy due to the thick layer. For the facade orientation, the building is specifically orientated facing the north and south. This is to minimize the solar gain and heat loss in the morning, and the glass interior facade allowed the natural views and sunlight into the building, allowing visual exchange between indoor and outdoor spaces. For the natural ventilations, the building placement in response to wind returned to its original flow pattern after encountering obstacles such as plants and buildings. Pressure differences, flow patterns, and the size and shape of the wind-protected area behind the plants control the air motions inside and outside of the building. For the courtyard building form, glazed glass causing large surface exposing to the sunlight, trapping heat indoor higher compared to shaded buildings. The Venturi effect helps introduce wind movement into the building for natural ventilations and natural cooling. For the wind buffer area, it lowers down the temperature at exterior areas such as admission center, halls, classrooms, and studio are ventilated through air conditioner. The window facade can have a severe impact on the heating and cooling loads of a building, but because of the opening in the center which holds a cooling courtyard, it helps to reoxygenating the air and removing airborne toxins. Cross and stack ventilation occur due to the differences between one side of the building and the other, due to the height differences from two different structures causing high pressure windward side and is drawn out on the lower pressure side of the building. For strategic landscaping, the vegetation in the landscaping of NTU is placed strategically to help cool down the building in the daytime. This can be seen from the planting of vegetations on the east side of the campus, creating a shade buffer from the morning sun. For waterscape, it is unable evaporative cooling effect at courtyard, where heat energy is taken from water surface when water molecule evaporate to vapor. The swirling green roof is the most recognizable sustainable feature of the campus. It continues from the ground, extending the fill up on the roof of the building, reinforcing the concept of green continuum. There are four main materials that are being used in the green roof. The first one will be the mondo grass. It is a dark green color with fine leaf. It grows in low light density and it is suitable in the tropical climate. It also reduces growth of weed and requires sandy soil. The second one will be the Manila grass. It is low moving requirement and it is good wearing ability, and it is able to grow in low light density. And it also stabilizes soil in the erosion prone areas and low maintenance cost efficient. The third one will be the Ivalon Membrane. It is resistant to damaging radiations without protective coating, and it has good thermal and mechanical properties and low vapor diffusion resistance. The last one will be the volcanic rock. It has high porosities and high water holding capacity. The green roof helps to reduce stormwater runoff by absorbing the rainwater, hence reducing off-site flooding. It also decreases exterior noises, rainwater harvesting for landscape irrigations. It also improves air quality by lowering CO2 emissions and reduce thermal transmittance to interior as compared to generate roof, and also prolonging the roof lifespan.
Moving on to the Pixel building located at Melbourne, Australia with a temperate climate. Pixel is a future office, a prototype of the commercial buildings that will emerge when a carbon-constrained environment demands a greater focus on energy efficiency. Pixel is Australia's first carbon-neutral office building, generating all its own power and water on site. It scores a perfect 105 Green Star points and LEED points, where the extra 5 points for innovation, equating to world leadership. For site planning, Pixel building located on a key urban site at the Carlton and United Breweries Company. Accessibility-wise, it has pedestrian and cyclist-friendly lane with a walking distance to Melbourne Central and Victoria Market. Responding to the temperate climate, it has a passive heating system during the winter season. Besides that, the site has an even precipitation throughout the year, giving an opportunity for application of green roof rainwater harvesting system. From the site plan, we can see that Pixel building has an unmanipulable building orientation due to its adjacent context and limited space. Hence, playful kinetic facade become the most recognizable element in this building. It has minimal opening due east to reduce glare, low density of facade panel due south to receive more daylight, moderate density due north to control privacy from street, and high density due west to block evening sun. Australia has a fluctuating daylight hours. The longest average monthly sun hour per day is 14.5 hours from December to January, whereas the shortest is 9.5 hours per day in June. The daylight illuminance is controlled by an automated external shading facade system. It allows sufficient daylight into the space while preventing excessive glare. At the rooftop, the tracking photovoltaic panels have a control system that monitors their illumination and adjusts their direction to maximize light levels. Complementing with the wind turbine, pixel building generate more electricity than it actually requires. For user experience, the direction of facade panel will alternate according to the sun level and direction along the day. It frames the view and provides a borrowed scenery to the users. Part of pixel building is a composed system of shading lowers, perimeter planters, double glazed window wall, and solar panel shading. The recycled aluminum panels provide maximized daylight, shade, view, and glare control by alternating the direction of facade panels. Secondly, the rooftop solar panel is utilized as a shading device for discussion and as a renewable energy source. The colorful aluminum panels not only being attractive externally, but also enhance the interior working space to be more cheerful and stress reducing. The facade pieces are arranged scientifically to cast alternating shadow pattern along the day. In the section, we can see perimeter planters as a cavity layer between shading panels and inner glass to reduce heat transmittance. The inner skin of the facade uses double glazed low emissivity glass, which reduces the need of artificial illuminance and aids in energy saving. Low E glass reduces heat gain and loss by reflecting long wave infrared energy, which also decreasing the U value and solar heat gain. Besides, the ultraviolet ray which can damage interiors can be minimized. For natural ventilation, Pixel Building has a smart window system that opens automatically during non-office hour to enable night purging. So the heat in building escape and reduce indoor temperature. At the same time, the thermal mass of concrete floor will be cooled, which can reduce the load of cold water system on the next day. The building has a self-sustaining heating, ventilation, and air conditioning system for energy efficiency. Firstly, the exhaust riser. For the user's spatial quality, 100% of fresh air is circulated throughout the building at 3 times the rate required by building code, and it is controlled via floor vents at each workstation. Hence, it has an even distribution of fresh air for every user. Despite the site context without planting space around the building, Pixel managed to achieve zero carbon and zero energy through strategic landscaping. It has a green roof that filters and harvests rainwater, reduces stormwater runoff, as well as providing thermal insulation during summer and prevent heat loss during winter. The green roof also provides green space for users in their workplace, which can relieve mental fatigue and improve work performance, satisfaction, and alertness. The strategic landscaping of green roof and reed bed enable a self-sufficient and environmental-friendly water system in a building. Firstly, the rainwater is harvested after irrigating the roof garden. Rainwater is stored and treated by reverse osmosis to potable water standard. The treated water is distributed to all fixtures and fittings within the building. The grey wastewater is then filtered and directed to irrigate the reed bed, which can treat grey water through evapotranspiration. As a result, there's no grey water waste leaving the pixel site.
So moving on to the third part, which is comparison. So we did comparison for the 3 aspects. So for the first one, which is site planning. So we did a conclusion, which is the both buildings, they respond to the climate region. NTU and at the tropical climate, they focus on the heat insulation and stormwater absorption, whereas the pixel building, it has a heating system during winter. So for both buildings, they also respond to the sun path and wind path. NTU orientates its facade to the north and south facing, whereas the pixel has minimal penetration due east. So the next one is daylighting. NTU is located in a tropical climate, whereas Pixel is located in a non-tropical climate. And each building came out with their own unique design and also method to maximize the daylight illumination building has implemented, which is using the double glazed low emissive glass. With the implementation of the low E glass, both building has achieved maximum daylighting efficiency. And the next one is facade. So they actually implemented 2 very different passive strategy. So for the first one, the facade for NTU, it actually promotes a passive design strategy which is attached directly onto the building and cover majority of the building. And the face building does its own job without any help from other elements. So for Pixel, the passive strategy, which is it's attached directly onto the building and also cover majority of the building by using recycled color panels, providing like maximize daylight, shade, view, and glare control. So the next one moving on is to natural ventilation. Conclusively, NTU uses more simple way to bring in airflow into the building, but the aim is also simpler, which is to bring comfort compared to the pixel building. And for the pixel building, it uses a more complex method and to achieve a ventilation because of their site disadvantages, but they make better use of the wind than NTU, which is to generate electricity as well. And the last one is strategic landscaping. In NTU and also Pixel, they both have green roof, and for NTU, they have a courtyard waterscape, which is very efficiency in evaporating cooling and also battery effect. But then they have like exterior plantings, which is NTU planted around the site to filter prevailing wind, and also the continuation of grass landscaping onto the roof as a natural cooling system. But for Pixel, they have a green roof, but then they uses a perimeter planter. In result, they have a self-sufficient water system. So on the other hand, this Pixel, they actually applied this green roof as a self-sustaining water harvesting and also treatment system for irrigation and potable use. It also uses reed beds and to treat grey water before discharging.
So that is all for our presentation. Thank you very much.